All right, lesson 12.4 is going to talk about finding the measures of angles that are formed by chords, secants, and tangents, and the combination of those things, as well as how do we find lengths of segments that are associated. So like a secant or a chord or a tangent secant, tangent chord, all those different kinds of variations. So the first thing we need to do is define what is this thing that's called a secant. Very simply, a secant is a line that goes through the circle twice. If you remember, a tangent went through the circle once. A secant is a line that goes through the circle twice. Now, if you look at a secant and you just focus on what's going on inside the circle, that part that I just put there in blue is what we call a chord. So a secant is the line. A chord is a segment of the line that is inside the circle. All right? So let's look at the first theorem here. The first theorem says the measure of an angle formed by two lines that intersect inside of a circle. The measure of an angle formed by two lines, let's draw one line, that intersect inside of a circle. So let's say something like this is occurring. Okay? Now, when this occurs, I recognize a few things. First of all, I know we've got all these intersections with the circle. So I'm going to name these A, B, C, and D. All right. I know that if I am looking at angle 1 here, if I'm looking at angle 1, I know that its vertex is just kind of floating around here inside the circle. All right? This is a special scenario. Up to now, we've looked at central angles and inscribed angles. Central angle, the vertex is in the center. Inscribed angle, the vertex is on the circle. Now, this scenario, we have a vertex just floating around inside the circle. This creates for us two different arcs that angle intersects. Okay? So here's what I know. The measure of angle 1 is going to be equal to half of the sum of the two intersected arcs. All right? I know that the measure of angle 1 is half the measure of this arc divided by the measure, plus the measure of this arc. All right? So these are getting a little bit tricky. You really got to think through how to do these. Okay? The next theorem says, what if you have an angle formed by two lines that intersect outside the circle? All right? So let's look at two lines. Let's say that we have this line right here, which would be a secant. And let's say that you have this line right here, which would be another secant. Now, when I'm looking at this, the first thing that jumps out at me is there's the vertex. So this is the angle that they're describing. Again, I called that angle 1. Well, I know that this angle intersects here at A, B, C, and D. So what they're specifically talking about here is here are the two intercepted arcs of that angle. All right? This equation is slightly different. So what we know here is that the measure of angle 1 will still be half, but instead of adding the two arcs, we're now going to subtract BC, arc BC minus arc AD. And that will give me the measurement of that angle. Now, here's how I keep it straight for myself. All right? I know I'm going to kind of go through all four scenarios now. Scenario number 1, vertex is at the center, equal to the intercepted arc. Option 2, vertex is on the circle, equal to half the intercepted arc. Option 3, vertex inside, half the sum of the intercepted arcs. Vertex outside, half the difference of the intercepted arcs. You really have to train your brain to think about that. If it gets too confusing, come and see me and I'll give you another way that's a little bit more visual I can't quite do on the video. All right, so let's take a look at this first problem here. first thing I look at, they want me to find an angle and the vertex is out. In my head, I'm thinking subtract and take half. So to find x, I know this is going to be half of the difference. I have to take 160 minus 68 because if I took 68 minus 160, I would get a negative angle. Doesn't make sense. All right, so this is going to be half of 92, and half of 92 would be 46 degrees. So the hardest part about doing these problems is remembering, do I take half? Do I just say it's equal? Do I add and take half? Or do I subtract and take half? That's the hardest part about finding all these different angle pairs. All right, so how can they extend this a little bit? Well, let's focus on finding x first. I know that the vertex that would include x is actually right there, and they tell me that its measure is 50. No problem. I know that the angle 50 is equal to half of the difference, 160 minus x, half the difference of the intercepted arcs. Now, to simply solve this problem, I want to first get rid of that half, which means I got to multiply 50 by 2. So I have 100 is equal to 160 minus x. All right, I'm going to subtract 160, so negative 60 is equal to negative x. Wait a minute, that's not what x is. I got to divide everything by negative 1, and I get x is 60 degrees. All right, so if x is 60 degrees right here, then how do I find angle y? Well, to find angle y, I have to know the measurement of this arc. Why? Because I notice the vertex for angle y is on the circle. So it's an inscribed angle. All right, so let's see. First off, I need to take 360 minus 160 plus 60, which would be 220. And that tells me that that missing arc is 140. So to find y, I have to be inscribed angle. I have to take half of arc that's measured as 140. And that tells me that angle y is equal to 70 degrees. Okay? All right, let's take a look at this third example here. I have an angle whose vertex is outside. In my mind right now, I'm thinking subtract and take half. The problem is I only know, this is a tangent-tangent scenario, I only know that this arc is 120. I need to know this arc over here as well. Well, if I take 360 minus 120, I know that that arc is 240 degrees. All right, so if that arc is 240, then I know that angle x is going to be equal to half the difference. So 240 minus 120, or x would be half of 120, which tells me that x is 60 degrees. All right, so let's take a look at this next one now. All right, the first thing I'm going to do is try to find x. Now, there's a couple of different ways that I can find x. First of all, there's the vertex. The vertex is inside. I know I need to know this arc on this rim, and I need to know this arc down here. Well, I also notice that this line right here is a diameter. So I know that this side is 180 and this side is 180. So let's see, if that's 60 and that's 70, I know that this is 50. All right? So to find x, I'm going to take 1/2 of 180 minus 50. Or x would be equal to half of 130. So that means x would be 65 degrees. All right? Now, to find y, which is this arc right here, I have to use this vertex over here. So that vertex is telling me that angle is 53. So, okay, I know that 53 is equal to, the vertex is out, so I have to take half and subtract. Well, let's see. This arc is 180. And y, we don't know. All right, so to figure out y now, I'm going to get rid of this half by doubling 53. 106 is equal to 180 minus y. I'm going to subtract 180, so that gives me negative 74 is equal to negative y, or y is equal to 74 degrees. Okay, so the second phase of this is kind of tricky, but it's all based on where the vertex is. I'm going to do my best. If this doesn't make sense, you need to come in and see me, okay? I have 3 different scenarios for how to find lengths of sides. So remember, everything we did so far in this lesson involved angles, when the vertex is inside and when the vertex is outside. Now, how do we find segment lengths when the vertex is inside and the vertex is outside? There are 3 possible scenarios. Scenario 1 is the vertex is in. If the vertex is inside, then we're going to take A times B and set it equal to C times D. And that's what this formula right here is telling me. The second scenario is if the vertex is outside. All right? If the vertex is outside, this is the way that I think about it. I have to measure to the circle and to the other side of the circle. So W times W plus X equals Y times Y plus Z. And if you look at the equation, they just wrote it a little bit different than the way I said it. So you got to measure to and to the other side. To and to the other side. This is how you handle it when the vertex is outside and it's a secant scenario. What if I have a tangent secant scenario? Well, I use the same rule. I'm going to measure to the circle and to the other side of the circle. Well, this one's a tangent, right? So that means it's only going to hit the circle once. That's how we get the t squared. The other one is a secant. So I measure to the circle, that's y, and then to the other side of the circle, that's y plus z. And that's how I get that part of it. All right, so let's take a look at a couple of problems, see how we can do. First problem here, I recognize the vertex is in. When the vertex is in, we're looking at a chord scenario. Chord says take 8 times x equals 20 times 6. Or 8x equals 120. All right, if I pull up my handy dandy calculator, take 120 divided by 8, I get 15. So I know x is equal to 15. Again, how did I figure out what formula to use? I looked for the vertex. Vertex in. To the circle, to the other side of the circle. To the circle, to the other side of the circle. All right? Scenario number 2, vertex out. Okay, this one I got to think a little bit more. It's a secant scenario. So I know that I'm going to take the measurement to the circle, 11. The measurement to the other side of the circle, which would be 11 plus 20. And that has to be equal to the measure to the circle, 13. And the measure to the other side of the circle, which is, I'm going to say that that's a C. And I'm going to take 13 plus C. All right, so this is going to be 11 times 210. That's right, 11 times 20 is 210, right? 220, duh. All right, so 11 times 220. Oh, what am I doing? Let's try that again. I have to add. That's what that symbol means. So I have 11 times 31 is equal to, now in 13 here I have to distribute. So that gives me 169 plus 13C. 11 times 31, let's do that on the calculator. 11 times 31, 341 is equal to 169 plus 13C. All right, I'm going to subtract 169. So if I take 341 minus 169, I get 172 is equal to 13C. And then divide by 13, and that gives me 13.2. Hold on, let's look at the directions here. If necessary, round to the nearest tenth. So if it's necessary to round here, I would get 13.2. You got to measure to the circle and to the opposite side or the other side of the circle. All right, in this next one, we got to find both x and y. All right, so let's try this one now. From this vertex, I'm just going to focus on x here. I know it's 7 times 15 plus 7, which is 22, is equal to 5 times 5 plus x. All right, so 720 times 22. And again, remember that 22 came from 7 plus 15. So that'd be 154 is equal to 25 plus 5x. All right, I'm going to subtract 25. And that tells me that I have 129 is equal to 5x. I'm going to take that 129, come on calculator, there we go, and divide that by 5. And that gives me 25.8. X is equal to 25.8. That's right, wasn't it? 25.8, yes. Okay. So there's our x. Now, to find y, I'm going to do this in red. The vertex is still outside, and I want to use this secant because I know both the pieces, and this tangent is where y is. All right? So to find y, I know that y squared, y times y, is equal to 7 times 22, measured to the circle to the opposite side. So y squared is equal to 154, or y is equal to the square root of 154. Now, I'm pretty confident that's not a perfect square, so I'm going to take 154 and take its square root, and I get 12.4. All right, last problem that we're going to look at. So we got to find x and y here. Now, to find x, let's see. I know that the vertex here is on the inside. I'm trying to see. I can't quite do this problem, though, by using that vertex because I have 9 and y, 5 and x. So in this particular problem, to find x, I got to start out here. And here's what I know. The tangent, which would be 11 times 11, or 11 squared, is equal to 7 times 7 plus x plus 5. All right, so 7 times 7 plus x plus 5 would be x plus 12. 7, x, and 5 added together give me x plus 12. So this gives me 121 is equal to 7x plus 84. And grab my calculator. I have 121 minus 84 be 37 is equal to 7x. And then I'm going to divide that by 7 and round to the nearest tenth, so that would be 5.3 in this case. X is approximately 5.3. All right. Now, here's the tricky part on this question. I have to use a rounded measurement in order to find y. So I'm going to do my best to not use that rounded measurement. In other words, here's what I know. To find y, I have to use this vertex. I know that 9 times y, or 9y, is equal to 5 times x. Now, if you remember, on my calculator, I had x out to a lot of decimal places. All right? I'm going to take that number, that's x, and multiply it by 5. And that gives me this number, and then divide it by 9, and that rounds to 2.9. So I use my calculator here to figure out that x would be, y would be approximately 2.9. All right? Hope this helps. Let me know if you have any questions. Don't put this off till the last day.